Good afternoon. Welcome to Michael Ossmann's talk, GreatFET, Making GoodFET Great Again. You are in South Seas GH. Hopefully you knew that. Before we begin, a few brief notes. Stop by the business hall located in Bayside AB during the day and for the welcome reception from 5:30 to 7 tonight. The Black Hat Arsenal is on the Palm Foyer on level 3. And please join us for the Pony Awards in Mandalay Bay, B, C, and D at 18:30. Please also put your phone on vibrate. It makes it easier for the rest of us to ignore your ringing while you wait for your voicemail to pick it up. Without further ado, Michael Ossmann.
Thank you. Thank you. GreatFET. It's time. You look at GoodFET. It's in bad shape. It's in very, very bad shape. You look at the software. The software is a horrible mess. We have the best people. Great people. We have the best licenses. Beautiful, beautiful open source licenses. All right, I can't keep this up. All right. When I submitted this talk months ago, I had no idea that Donald Trump for president would still be a thing. But here we are. I'm Michael Ossmann of Great Scott Gadgets, and I make open source hardware. And primarily, I make open source hardware for the information security community. And I've been familiar for a long time with the GoodFET project, which is, I'm sure as most of you know if you decided to come here, a wonderful open source hardware tool that has been popular for some years in the information security community in particular. And it's a pretty small, simple tool. It has just a couple of chips on it, and it is a USB interface with a bunch of pins at the other end. And you connect those pins to all sorts of different things. And it's a tool that has made hardware hacking accessible for a lot of people. In particular, one of those people that this tool inspired to get into hardware hacking is standing in front of you right now. The very first board that the very first surface mount assembly I ever did was a GoodFET that Travis Goodspeed handed me for free. And I'm sure many of you have similar stories that at some point you ran into Travis at a conference and he handed you a free circuit board, and that affected you in some way. That may have changed your lives like it changed mine. This is really the start of how I got into hardware. And now I've designed all sorts of things that some of you folks use, like Ubertooth and HackRF and Yardstick, and all of that started with GoodFET. In case you don't know Travis, I have here an original, totally unmodified photograph. Now, when I started with GoodFET, the thing I wanted to do was program the IMMe, my favorite pink toy. Travis actually introduced me to this thing too, and he was showing me how he could reprogram the thing in the hotel bar at ShmooCon several years ago, and he was using his GoodFET. He had soldered some little wires to the connectors there, the debug connectors that those pads that are available through the battery port or the battery compartment of the IMMe, and he was doing some things, just experimenting at the time, getting some basic radio functions going. This toy had been reverse engineered by a fellow named Dave from the UK, I believe. And Dave posted some information online, and Travis took that and ran with it and did a bunch of stuff and got it working, got the debug interface working with the GoodFET. Now, GoodFET originally was intended to be a debugger. And it gets its name from a previous FET that was a Texas Instruments product, a debugger for MSP 430 Texas Instruments microcontrollers. And Travis wanted to have his own version of this debugger that was more hackable. So he made the open source hardware GoodFET for that purpose. But then he started adding things to it. He was inspired by the bus pirate to turn it into a general purpose interface that could connect to SPI buses, I2C buses, all sorts of miscellaneous electronic interfaces that you might find on embedded electronics, like toys, for example. And in this case, the chip that's in the IME is another chip from Texas Instruments, but a completely different CPU architecture, completely different debug interface. And Travis just thought it was a cool toy, so he implemented that debug interface. And we could use the GoodFET as a debugger for the IME. And that let us do a number of things, but most significantly, we can read or write program data to the thing. So we can create our own software for the IME. And I was excited to do that. So as soon as I got home from ShmooCon, I ordered the parts I needed for the GoodFET PCB that he gave me, and I ordered the IME, and I soldered the GoodFET together, and wired it up. And this photo actually is maybe not in the best place for this story, because this is a little add-on I made for the GoodFET later that lets me connect to the IME with these spring pins, which is super handy when you just want to get an IME off the shelf and program it with your own firmware and then walk away. But at the time, the first time I ever did this, I was soldering wires to those little pads in the IME. And within a couple weeks, I had written a spectrum analyzer application for the IME that was super handy. I've used this thing a lot. And I know some other folks have used it too. It's a good example of how some piece of hardware can be repurposed. And this was one of the things that I thought was coolest about the GoodFET project. Not only can it be used like it was originally intended to investigate the security of embedded electronics, but it can actually be used for all kinds of other things, like repurposing electronics, repurposing toys. I got this toy for $16 on eBay at the time. Of course, these days you have to pay, upwards of $300 to get one on eBay? Thanks, Sammy. But you can repurpose electronics, and you can actually build electronics. The GoodFET was instrumental for me in building several of my designs. When I first started designing my own electronics, and I was working on the Ubertooth project, kind of the first, most rudimentary Ubertooth function that I got working was actually the chip that ended up on the Ubertooth board, the main radio chip, just wired up to a GoodFET. And that's how I was able to prototype the Ubertooth. And then later, I worked on HackRF, and there was this whole bootstrapping process you have to go through when you develop a new product. And I had a development, like an early design of a HackRF microcontroller board, and I needed to get code on it. And how did I get code on it? Of course, I turned to my GoodFET. Now, there have been many variants of the GoodFET project, many hardware variants. This one was a conference badge for the Next Hope. It's basically just a plain old GoodFET, except it adds a radio to it. There's a little radio chip just north of the crystal oscillator there. And it is a Nordic RF 2.4 gigahertz transceiver that's pretty convenient, pretty easy to use. It's a popular part in a lot of projects. But Travis made this as a variant of the GoodFET project and put a bunch of code in the GoodFET project for talking to that Nordic chip and implemented a whole bunch of cool radio functions, including some stuff that you can find on his blog, some influential work that he did doing things like sniffing Microsoft wireless keyboards. It's work that is still influencing wireless security stuff going on these days. And he developed a new technique for doing kind of promiscuous mode wireless sniffing using this chip that really isn't designed for promiscuous mode wireless sniffing. It's a great trick. And the GoodFET, it's a good example of the kinds of tricks that Travis has done with the GoodFET and that many other people have done with the GoodFET over the years. Probably the most popular variant of the GoodFET project is the Facedancer. I'm sure many of you have seen the Facedancer. The Facedancer is a USB probing device. And it is basically a GoodFET, just a regular old GoodFET on the left-hand side. But on the right-hand side, there's an extra chip and crystal and USB connector, and that implements a programmable, fully controllable USB device. You may notice that port is labeled victim because you can attach that to a target USB host and then attempt to attack that USB host. And this was really the first time that there was any awareness of how vulnerable USB stacks and hosts could be. People started plugging these things into hosts with very popular operating systems, and bugs just started falling out. It was amazing. Like the first year of Facedancer, so many bugs. It was a very simple tool that accomplished a job that nobody maybe ever really thought to do before. Nobody realized how simple it was to implement this type of attack. It really is not a very complicated device, and it enabled an amazing array of security research into USB hosts. Now, there are a few problems with GoodFET. And I first started talking to Travis about this quite some years ago, like maybe only about a year or so after I started getting involved with all this stuff. I was starting a company, and I was starting to build open source hardware, and of course that's mainly what I do now. I build open source hardware tools for people, and I try to keep them as low cost as I can, and I try to make them as accessible as possible so people can build them themselves or modify them and use them however they need to for security research and for practical testing of things and all kinds of functions. But the kind of key to my business model for Great Scott Gadgets is that I really want open source hardware to be what you have in your hand, what you have in your toolbox, so that you can have the power to do whatever you want with it. But I recognize that many people don't want to spend all their time soldering these things and putting them together. So I sell them. And you can build them yourself or you can buy them. But there are enough people out there who would rather buy than build that it's useful to there's more reach. We can get tools into more people's hands if we give people both options and not just require that people build them. So Travis was going around to conferences and just handing out free circuit boards, willy-nilly, and that helped a lot to increase the reach and the popularity of the GoodFET project. But it only reaches those people who actually are motivated to assemble them themselves. And it would be nice to actually be able to produce the things at volume and manufacture them and sell them for people who don't want to build them themselves as well. So he and I were talking about that a long time ago, since that was kind of the direction I was going. And I was looking at the GoodFET design, and I looked and I saw, what is this ridiculous microcontroller he's put on here? It is like volume pricing is like $8 or $9. And at the time, I think it was over $10 at volume. And it's a 16-bit microcontroller. There's not much to it. It's kind of comparable to some parts that you can get for around $2. And of course, this is the manufacturing costs. You know, these costs get multiplied as you get into production and distribution and so forth. So starting the project with such an expensive microcontroller seemed kind of ridiculous. But there was a reason for this part to be in there. There were a couple reasons for this part to be in there. And one brilliant aspect of this part selection was that you could get free samples of this part from Texas Instruments. You could just go to the website and say, hey, I want 2 of these, ship them, boom, and you'd have them. They did like 2-day shipping or something, and like free. You didn't even have to pay for shipping. They just show up at your door. So for those people who are building them themselves, fantastic, wonderful part selection. But then when I started looking at what would it take to manufacture this thing in volume, I thought, this is ridiculous. I can't, just because of this part, I can't manufacture this thing and sell it without making it significantly more expensive than an Arduino. I mean, it was crazy. And so I started thinking about different architectures. You know, what might we be able to do to just completely revamp the project and switch to a different CPU architecture. Now, there's another part on the chip that is also kind of interesting. I mean, there are only 2. The other part on the board. There are only 2 chips on the board. Here's one of them, and the other one is this one. It is just a USB to serial adapter, and it's kind of expensive for what it does also, especially when you consider that many microcontrollers have built-in USB device controllers. So you maybe don't even need a part like this on the board. And then over time, strange things started happening. What was that sign you were holding up over there? Joe Grand came with a sign, FTDI gate was an inside job. Or was it Joe Fitz? Or both of you at one point or another? The FTDI gate was this crazy thing. The company FTDI that makes this particular chip started doing some pretty unneighborly things. And they have a problem, like many electronic component manufacturers do, with counterfeit parts on the market. And they took the extreme measure of pushing an update to their official signed Windows driver for this chip that bricks counterfeit parts. So of course, a lot of counterfeit parts, can find their way into places where people don't expect them. And products that had this chip inside them that got manufactured with a counterfeit somehow suddenly got bricked in production. And it was pretty unfriendly. And that was just the first thing that they did. I'm not going to continue, but you get the idea that it would be nice to get away from this particular chip if we can. And those are the only 2 chips on the board. So it kind of made me start thinking about a total redesign. Here's another aspect of GoodFET that's interesting. If you look on the left-hand side of the web page there are over 20 hardware variants in the project. And the software is, of course, the complexity of the software kind of follows suit. And many of those variants, especially the ones in the top half of the list, have special functions, like that radio chip that was added to the Next Hope badge. Special function GoodFET. You needed a separate board just to implement that function. Or the Facedancer is a good example. Special function USB attack tool. You needed a special GoodFET just for that function. And so there's a lot of complexity in the project, both in the hardware designs and the software designs. And if you're a user of the GoodFET project and you're a fan of trying all these different functions, you end up with a whole bunch of different boards in your bag. And this is kind of a problem, I think. Something I hope to find a way to avoid if we were going to kind of freshen the project. Here's another example of a kind of a drawback of the GoodFET project. This is just a little snippet of code that's doing some bit banging. Stop race conditions, it says on a sign down here. There's this popular technique that we, all embedded developers do this from time to time. We do bit banging, which means we have some code that says raise the voltage on a pin and then lower the voltage on a pin, and then we do that a whole bunch of times with little timers in between, and oftentimes the timers are really stupid, like just looping over some knobs or something, and this technique of bit banging is very useful because it's extremely flexible when you're developing it for the first time. But when you want to go back and maintain code or make it compatible with other targets, it's not necessarily the most flexible thing. If you want to change the speed that it's running at, you have an interface that's running at 500 kilohertz and you want to run it at 2 megahertz or something, it may not be really obvious and easy to do that if it's bit bang code. And there are peripherals. There are little add-on components inside microcontrollers that do a lot of these kinds of functions for you. This particular one is an I2C interface from GoodFET. We're bit banging I2C with GoodFET, even though the chip has a special purpose I2C peripheral built in. We're just not using it. The I2C peripheral is higher performance and is relatively easy to use from a programming standpoint. And it would be nice if we could use some of those built-in peripherals. Here's another example of performance with GoodFET projects. This is the Facedancer, which is maybe the most popular GoodFET board that exists. It has full-speed USB connection to your host computer, and then it has another full-speed USB interface, 12 megabits per second. That's a connection to the victim or the target host. And in between the two, there's a 1 megabit per second serial link to control that USB controller. So it's this tremendous bottleneck. And anyone who's tried to do anything significant with Facedancer has probably noticed that the performance is atrocious. But keep in mind that all of these things, all of these design choices, they happened organically, and they happened by people like Travis and other folks who were contributing to the project, who were trying to get something working for a conference, trying to demonstrate a proof of concept. In a lot of cases, they were doing important research, and they did what needed to be done to get that research done. And in that respect, the project has been a tremendous success. But looking to the future, the project could be a lot better, especially as a usable tool to reproduce other people's work and to make this kind of research and this kind of hardware hacking more accessible to a much greater audience. So the first redesign I attempted was called the GFLPC 1343. I didn't give it any kind of a special name because I wasn't sure if it was going to go anywhere, and it didn't. But I made some of them and I played with them. My concept here was keep it small, keep it low cost, reduce the cost actually. Don't really change much except make it cheaper and a little bit more powerful maybe. It still has a full-speed USB interface. It's a one-chip solution instead of a two-chip solution. It's using the LPC 1343, which is an ARM Cortex M3. It's a little faster than the 16, it's a 32-bit CPU, a little faster than the 16-bit CPU that's on the original GoodFETs. And I doubled the number of pins exposed and put them across from each other so you could kind of make add-on boards that would plug in. But it was very, very small. And so add-on boards didn't have a whole lot of room. And if you're trying to make an interface for add-on boards, it would be nice to have more pins than that. But I was kind of excited about this at the time. I thought this could be the next generation GoodFET. And in particular, I would say that the number one design goal I had was to make this lower cost. Do the same things that GoodFET does, but do it at a lower cost. Still easy to assemble yourself, relatively, a few more components to solder. but much, and still affordable to assemble yourself, because even though you can't get that chip for free, it only costs like $3 or something like that. So it's still affordable to assemble yourself, and it was much more affordable for volume manufacturing. So I thought I might be kind of onto something. And I made a version of this for the H2HC conference in Brazil. This PCB was intended to be in the shape of Brazil, but that turned out to not be very practical. So we just made it rectangular and kind of stuck the GFLPC 1433, 1343, and added a couple little buttons to make it a little bit more convenient to program. And we had these things manufactured for H2HC. So they were manufactured in China, and the manufacturer sent me a picture of the printed circuit board before they started assembling components on it. And then they assembled them and shipped them, and this is the last I ever saw of them. If you would like an H2HC 2013 badge featuring the GFLPC 1430, whatever it is, 1343, you need to talk to the Brazilian Federal Police because they have them all. Or at least they did. I doubt they still exist. So that was a shame and kind of a downer. I was kind of excited about the project at the time, but I didn't get very far with the firmware. And for this particular conference, the H2HC conference, the conference organizers were kind of excited. They weren't necessarily excited about having a new GoodFET, but they were more excited about just getting people in their community kind of interested in embedded systems and embedded hacking. And a GoodFET could be good for that, but just having an embedded system that's easy to program could be a really good start. And so even without giving them very complete firmware, it was that. And then there was, of course, always the option to upgrade it in the future with a firmware update that would make it do GoodFET stuff. And I thought that was a pretty good approach to take, but that means I didn't actually get very far on the firmware. And so by the time of the conference, there we were sitting around with no badges and very little firmware. And I kind of got down on the whole concept, and it wasn't super compelling to me to kind of revive that project. And I think the reason it wasn't super compelling to me is that GoodFET had a lot of interesting things going on, and I didn't really see that just reducing the cost was going to take the project to the next level. I think that's kind of the target I was aiming for, was just make GoodFET lower cost. And it started occurring to me that maybe it would be better, instead of aspiring to cheapness, to aspire to greatness. And around the same time, somebody, and I don't remember who it was, it might have been Dominic Spill, just started referring to this project as GreatFET. Because my company is... My company is Great Scott Gadgets, so the Great Scott Gadgets version of the GoodFET would be GreatFET, and we thought that was kind of amusing, and so the name sort of stuck, but the GreatFET project really died at this point because, and I think maybe it was the name GreatFET that made me think, I shouldn't be making something lower cost, I should be making something greater. GoodFET could be even greater than it is, and ever has been, if we aspire to greatness. So I kind of threw that project aside. It's out there. You can find the hardware design in the GoodFET repo, but nobody uses it. I started thinking in a different direction, but it took me a long time to actually make progress in a different direction. But eventually, I did. And this is the first real GreatFET board. Code name is Azalea, but we're going into production right now for volume manufacturing, and we're changing the name to GreatFET 1 because I'm not very original like that. Maybe the next one will be GreatFET 360 or something. GreatFET Tau. So anyway, GreatFET Azalea is becoming GreatFET 1. The hardware design has been stable actually for almost a year. There's a date on there, October. It's been stable since October. We're making maybe one or two very minor changes as we go into production right now, just for manufacturability and reliability, but nothing significant. This is really the design as it has existed all year and will continue to exist for a while. So you can see it's significantly different than GoodFET. It's primarily a one-chip solution, one big chip, but then there's a bunch of extra components for various functions. The highlights are that on the left-hand side there you have a USB interface to your host computer, just like you always did with GoodFET. In the middle there's a big microcontroller, just like there always was with GoodFET. But now it's a much, much more powerful microcontroller. It's a 32-bit ARM Cortex M4 that operates up to 200 megahertz. It's the same chip, or nearly the same chip, as the one that we put in HackRF1. And this was a big part of why we decided to go with this architecture, is that we had experience with this part with HackRF1, and we meaning myself, Jared Boone, Dominic Spill, a lot of people involved in the HackRF project, we kept thinking of different uses for this microcontroller because it's so powerful in so many different ways. And we kept thinking, boy, we should really have like a general purpose, low-cost development board for this microcontroller to do a lot of fun projects. And that kind of started making me think that this is the part that should actually be on the GreatFET. This is a part that can make GoodFET great again. And it has a built-in USB controller, so we don't need a separate USB to serial interface. It actually has two built-in USB controllers. So guess what? We can just stick a target USB port on there, and it's a Facedancer. So we can do Facedancer-y things without having to add any kind of an add-on board. So the idea is that we can be a better GoodFET and be a better Facedancer and provide an expansion interface that lets us plug in a lot of different functions as pluggable modules. So instead of having a completely different GoodFET to do some wireless attack, we can just make a very simple add-on board that plugs into the big expansion headers and puts a little wireless interface on it. So for those functions that do need extra hardware, make it modular instead of requiring an entirely new main board for every little variant. So those are the main features: the expansion interface, the big microcontroller, the two USB ports. It's very easy to program, and this is one of the things we liked about this chip. And if any of you have used the HackRF1, you may have experienced this, that you can do firmware updates where you have like one firmware load the next firmware. But if you brick the thing somehow, all you have to do is push a button, and then it activates a ROM bootloader that lets you load firmware over USB. So you don't need any extra programming hardware to unbrick it. It's kind of unbrickable. And this is a feature, there was a similar feature in the microcontroller that was in GoodFET. And that was a feature that I really appreciated as a user of GoodFET, especially when I built my own board. It was the first board I built. I soldered it all together, I plugged it into a USB host and crossed my fingers, and when there wasn't any smoke, I was able to load firmware onto it without having to have another hardware programmer to load that initial firmware. So it solved the chicken and the egg problem that a lot of people have, a lot of electronics hobbyists have, where they have to like buy a programmer just to program the board that they built. GoodFET can be your first board that you build, and you can use it, and you can bootstrap it by itself, and then you can use it to help you build other things. And so this was a very important feature that I was excited about having in a replacement board. If there's going to be something greater than GoodFET, it should still have certain features of GoodFET. It should still have the ability to solder it with an iron. Okay, it's a little more complicated, it has more parts, but it's still possible to solder with an iron. And in every prototype batch we've made, we've always soldered at least one of them with an iron, just to make sure that that's possible. And it should still be something that we can bootstrap. We should be able to build a board, plug it into USB, and just with the push of a button, activate a built-in ROM bootloader that lets us bootstrap the process of loading firmware onto it for the first time. And we should also maintain some other GoodFET traditions, like licensing. Licensing of the GoodFET project is very, very permissive. Travis has used BSD-style licenses, and so we are actually we are in the process of relicensing some code so that we can honor that tradition and make all the hardware and software in the GoodFET project under permissive open source licenses. I've done a lot of GPL stuff in the past, but I think it's important, especially for this project, to honor that tradition and use the most permissive license I can, something that kind of follows the GoodFET tradition. Another great tradition of the GoodFET project is the Python interface. Probably the best thing, the thing that makes GoodFET so accessible is that you plug it into a computer and then it gives you a very easy to use Python interface. Oftentimes you can do functions from an interactive Python shell in just a few lines. Popular thing to do might be dumping spy flash or something. And so you can either do that in a Python shell or you can do it with a simple command line tool. It's a peripheral. And when you look at something like Azalea here or GreatFET 1, you might think, oh, look at that big expansion interface. This is an Arduino. And it does have some similarity. It has some similarity to those kinds of boards like Arduinos where you can put add-on boards on them that are embedded development systems. And probably the key thing that you can do with GreatFET that you can't with Arduino, well, you kind of can with Arduino, but the key model that we have is that this is a peripheral that's easy to use from a Python interface, as opposed to being an embedded system for doing embedded development. It's a little bit of a different usage model. So I wanted to do a little demo, and I totally didn't set it up because we had a little trouble getting coordinated to get me here on time. So I think I'm gonna skip my demo, but I'm gonna show you my setup here. I found this weird wireless storage device. You like plug SD cards into it, and it's network attached SD cards, something like that. And I thought, what use is this? I should rip it apart and see what's inside. And I took this board out of it. It's on the right-hand side there, and I wired it up in my hotel room. And I had very poor wiring for this purpose. But I was actually able to talk to the SPI flash chip that was on the target board. And this interface was super brittle, and like I had to hold it in just the right way, but then I could talk to the SPI chip. And this is a very common function that people have always done with GoodFET, is dumping firmware off of embedded systems or modifying firmware on embedded systems. And with GreatFET, we are doing that, and we're doing it now with code that takes advantage of the SPI peripheral that's in the microcontroller instead of having to bit bang everything. But we're doing it over a really easy to use interface on the host computer. All the host code is entirely written in Python, which is actually a major departure from the HackRF project from which some of this derives. So all the host tools are entirely written in Python. If your board has firmware on it, you don't have to compile a thing. You plug it in, and you can do things like dump flash. Now, I actually then prepared a slightly different demo to bring over here that was less brittle. I totally cheated by using one GreatFET to attack another GreatFET. I'm like, well, the GreatFET has a SPI flash chip on it too, so I can use it as a target. Yeah, so anyway, I was going to do a demo that just dumps flash, but I'm going to skip it for time. And anyway, it was kind of a cheater demo because I'm targeting the exact same board that I'm using as my attack platform. But it does work. And it works basically in the exact same way as it does if you have a more legitimate target. Now, some of you may be wondering about this name FET. Where in the world does that come from? And it comes from the term flash emulation tool. GreatFET is not really designed primarily to be a flash emulation tool. GoodFET certainly wasn't designed to be a flash emulation tool. The thing that GoodFET was designed to emulate was a debugger from Texas Instruments that was called a FET. And it wasn't a flash emulation tool. But somewhere back in the lineage, there were debuggers that were known as flash emulation tools. And the idea is that, I mean, this technique goes back at least to the 80s. The idea is that you have some kind of a microcontroller or microprocessor, and how do you debug it? How do you do a single step through code and stuff like that? And a popular technique in those days was to actually remove the external storage, the program storage, ROM or flash, and wire in a debugger which emulates that storage. And that technique was used for debuggers for a long time. And so then when they started making debuggers that worked in a different way, they sometimes used the same terminology to refer to it, even though it wasn't a flash emulation tool. So just FYI, that's where flash emulation tool that's where the name FET comes from. Interestingly, one thing we can do with GreatFET that would be difficult to do with the Texas Instruments FET is we can emulate flash. I haven't tried it, but we could totally do that. So that's not its primary function, but we could do that. And we have a bunch of add-on boards that we're designing. We've started designing add-on boards. There aren't very many designs yet, but there are a few. We call the add-on boards neighbors. And those of you who know Travis Goodspeed know that he's all about neighborliness. So in his honor, we call them neighbors. And we have some neighbors for prototyping. We have a little NRF radio neighbors so that we can do things like the Next Hope badge. We have a spring pin neighbor for connecting to the IME if you want to program it. All kinds of things. And we have information on the wiki already about how to design a neighbor and what's required to make a neighbor. There are a whole bunch of interesting peripherals that are built into this microcontroller. So if you're interested in making a neighbor, if you're interested in playing with GreatFET, these are some of the things that you could use. And those of you who are into embedded development will see a bunch of familiar acronyms up here. But just to point out a couple, there's a general purpose analog to digital converter. So we could just, collect analog inputs in addition to digital inputs. There's a CAN. There are actually 2 CAN adapters. So we're planning to make a dual CAN bus neighbor. All kinds of interesting things that are available to us on this chip. External memory controller. The SGPIO interface in the lower right-hand corner is kind of a special thing because it's a very flexible kind of parallel / serial interface that is it has like a programmable state machine in it that's separate from the CPU. Super cool. Oh, and by the way, there are 2 CPU cores. This is an example of something that I would like to do with a neighbor. This is something from a project that I talked about a couple of years ago with Kyle Osborne. We were attacking serial interfaces that are on mobile phones. And so it turned out we were able to just plug a serial adapter straight into a mobile phone's USB port, not running USB, running serial. And just by having a certain valued resistor on the right pins, we could get a debug interface and get root on a phone. This kind of interface is difficult to find unless you have some kind of tool to probe it. So I tried to make something that was an add-on for the GFLPC 1343 at the time. And it was going to be a little add-on board. Didn't work out. Because, so it was called Toad, the totally over-engineered adapter detector. Instead of taking this ridiculous approach of trying to do everything under the sun to try to probe for those kinds of debug interfaces, I'm taking a slightly different approach and building from the ground up and just building up the essential features that I need to probe these kinds of things kind of one step at a time. So I'm starting simple and then building up more complex. So Foxglove is a neighbor that will probably be somewhere between this level of complexity and Toad's level of complexity when it's done. But for now, it's a level shifter board. So it simply lets you interface your GreatFET to things that have 1.2 volt logic or 5 volt logic or anything in between, which is something GoodFET never had. And kind of the last thing I want to show you is one of the things we're working on with GreatFET, and Jared Boone made heroic efforts today to try to prepare a demo for me that I'm not going to use. Sorry, Jared. Using that fun SGPIO peripheral as a high-speed logic analyzer. So we're working on that and using GreatFET as a logic analyzer and being able to pull data into PulseView or other SIGROC tools. And we have this wonderful open source software available to us that we can interface with that lets us make a logic analyzer. So one last little thing. That's ridiculous. Here it is again. And I'm going to get kicked off stage. Just in case Travis ever denies that I actually bought GoodFET from him for $5, he retweeted that. Thank you to all these people. I could not do this by myself. Thank you for coming.